This video is looking at the syllabus dot point, distinguish between myopia and hyperopia, and outline how technologies can be used to correct these conditions. The ability of the eye to function effectively in refracting and transmitting light depends on the shape and size of the eyeball and the clarity of the structures within the eye. The eye varies in shape and size from person to person. Much like the variations of other features of the body, the variations of the eyes are hereditary also. If the cornea or lens is not the right shape, or the eyeball is too long or too round, this will affect the ability of the eye to refract light and focus it accurately on the retina. The resulting difficulties in seeing are called visual defects and include myopia, also known as short-sightedness, where the foreground is in focus, yet the background is blurry; hyperopia, which is known as long-sightedness, where the foreground is blurry but the background is in focus; and lastly, astigmatism, where the whole image is distorted. These defects are usually not due to disease or illness, but are simply a result of how the body grows. The correct medical term for short-sightedness is myopia. This is when a person can see near objects clearly, but distant objects appear blurred. In an eye that is myopic, distant objects being viewed form a focused image that falls in front of the retina. When near objects are viewed, the image falls in the correct depth on the retina, enabling the person to see near objects clearly, hence the term short-sightedness. Myopia has several causes. The eyeball may be too elongated in shape, the refractive power of the cornea may be inadequate, or the lens may not become flat enough when the ciliary muscles contract. This results, as you can see, from the focal point lying in front of the retina and therefore a blurred image forming. Hyperopia is the correct medical term for long-sightedness. This is when distant things are seen clearly, but near objects cannot be seen in focus because the image falls behind the retina. Causes of hyperopia include an eyeball that is too short from back to front, so the eyeball is too round; a lens that is too flat and is unable to alter its shape adequately, perhaps due to a loss of elasticity in old age; or the refractive power of the cornea being too great for the shape of the eye. And as we can see here, the image falls behind the retina, so we end up with, again, a blurred image falling on the retina itself. There are a number of technologies that can be used to correct myopia and hyperopia. Visual defects such as these can cause distinct disadvantages to people if they are not corrected. Myopic people would have difficulty in seeing traffic signs, watching television or movies, recognizing others, reading street signs and bus numbers, or even pursuing leisure activities such as archery, flying, cricket, and tennis, to name a few. In the past, myopia would have been hazardous in a different way, hindering activities essential for survival, such as hunting and scanning the horizon for predators. People who are long-sighted would often have difficulty reading books, newspapers, or computer screens, manipulating tools or machinery that involve close-up hand-eye coordination, or carrying out leisure activities such as chess, sewing, or knitting. Technologies available to correct these visual defects are therefore of major advantage to society. To compensate for refractive errors in the eye, technologies offer people the option of using corrective lenses, such as spectacles or contact lenses, or more recently, the option of laser eye surgery. So first we're going to look at spectacles, or more commonly known as glasses. The first spectacles were made in Italy in about 1280. A single magnifying glass had been used prior to this time. Spectacles are frames that hold corrective lenses in front of the eye. In the past, the lenses were made of glass, but nowadays many of them are made of a clear, hard plastic. This advance in technology has the advantage of the spectacles being lighter in weight and less easily broken. Of further benefit is the fact that shattering of the spectacles no longer carries the risk of tiny splinters of glass entering the eye. Glass, however, does not scratch as easily as plastic does, and does not become hazy over time. Myopia can be corrected by wearing spectacles with a concave lens, which is thicker towards the outside and thinner towards the middle. These lenses bend the light rays outwards, causing them to diverge before they reach the eye. This helps to extend the focal length of the light rays, allowing a focused image to fall on the retina instead of in front of it when a distant object is being viewed. Hyperopia can be repaired or reduced by wearing spectacles with convex lenses, which are thinner towards the perimeter and thicker towards the center. These lenses will bend the incoming light rays inwards, causing them to begin converging before they actually reach the eye, which helps to shorten the focal length and allow the focus image to fall on the retina rather than behind it. Advances in lens technology led to the first successful use of contact lenses in 1888, made by a Swiss physician, Dr. Eugene Frick. Contact lenses are a type of technology that is based on similar principles to glasses in terms of the shape of the lens and the refraction of light. Although the basic structure of the lens used is convex or concave in shape, the overall lens shape is often fitted to the curvature of the eyeball. Contact lenses are much smaller than the lens of glasses and are worn directly on the surface of the eye. The first contact lenses were very large, made of glass, and brought the wearer extreme discomfort. Further advances in technology have resulted in 3 types of more comfortable and effective contact lenses being currently available. Hard lenses are small, made of glass, and cover only the central area of the cornea. Soft lenses are larger, more flexible lenses made of a type of plastic compound that contains 30 to 70% water. These lenses cover the entire cornea and are most comfortable to wear, but not quite as efficient at correcting vision as the small hard lenses. Gas-permeable lenses are similar to hard lenses but are porous, allowing an exchange of gases between the surface of the eye and the outside air. Their main advantage is that they can be worn for long periods of time. The advantages of wearing contact lenses compared with spectacles have long been debated. Nowadays, advantages of contact lenses are not only for the correction of visual defects, but include contact lenses being used for cosmetic purposes, such as colored contacts, advantages while playing sport, especially in contact sport where you don't have to worry about being hit in the face while wearing a pair of glasses, the use of contact lenses in the entertainment industry, as we've seen in movies and things, doing away with the need for prescription sunglasses, as sunglasses can be worn directly over the contact lenses, and now contact lenses that can block UV radiation to stop the retina being damaged by the sun. Refractive eye laser surgery is another type of technology and is a fairly new and current direction of research into correcting the visual defects of myopia and hyperopia. It involves the use of lasers to change the curvature of the cornea, to alter its refractive power, compensating for any visual defect in the eye. The lasers are usually computer operated, and there are currently 2 different types being used. LASIK surgery involves cutting and lifting a flap in the cornea, leaving it partly intact. This allows the surgeon to introduce the laser to the middle layers of the cornea beneath the lifted flap, sculpting and shaping it before replacing the flap and flattening it against the newly shaped surface. PRK, or photorefractive keratectomy, surgery involves the removal of the epithelium, which is the outer membrane of the eye, and the surface of the cornea. The laser is then used to shape the uppermost surface of the cornea. The epithelium then takes 2 to 3 days to grow back. Current laser surgery is replacing the previous technique of radial keratectomy, where fine surgical instruments rather than lasers were used to shave the corneal surface. So what I'd like you to do, just to finish off, is to complete the activities in your booklet under these 2 dot points, or under this dot point, sorry. There are 3 parts, including a labeling activity, some true or false questions, and defining some of the key terms that we've looked at.